Example 8.4.1. With this one, we're going to find the stock's expected return given the current price and expected future cash flows. So we're switching gears a little bit here. What we've done in the previous examples was calculate what we call the intrinsic value, where we get that by mapping out what we think the expected future cash flows are. We discount those back at a rate that accounts for the riskiness of those cash flows, and we come up with the intrinsic value. That present value is the intrinsic value, what we think the stock should be worth. What we're going to do now is we're going to project what we think the future cash flows are, and over a very short period, right? Because that's obviously very difficult to do accurately, especially as you get further and further away from the present. And we're going to look at what the current price is on the stock so that we can then calculate what our expected return on the stock is. Now, this is not necessarily a return that's going to compensate us for the risk of the stock. This is not the capital asset pricing model's minimum required return. This is what we think the stock is actually going to do. Once we know what we think the expected return is, then we can calculate the required return and compare those things. This is really just the other side of the coin. In the earlier examples, we had a minimum required return from the capital asset pricing model. We found an intrinsic value for those cash flows, and then we compared that with the price. Well, here we've just kind of flipped the coin over. Now we're going to include the current price, and we're going to come up with an expected return on that stock. And then we're going to compare that, well, in a later example. Here, for this one, we're just going to calculate the expected return. And then the next example, we'll actually compare that to the required return from the capital asset pricing model and see if we expect it to offer enough return to justify its risk. So that's the path we're starting down here. This first one, 8.4.1, is pretty straightforward, so we'll just walk through the example as it is. The setup says, suppose you are considering buying a stock. The stock is currently trading for $50. You expect the price in 1 year to be $51 and will pay a dividend of $5. What is your expected rate of return if you were to buy the stock today, hold it for 1 year, receive the $5 dividend, and then immediately sell it for $51? All right, time value money problem. So we're going to start by mapping out the timeline. We've got a current price of $50. That's what it's trading for today. And we're going to look at this from the perspective of us as a potential investor in the stock. So it would be a cash outflow if we bought it today. 1 year from today, we expect the stock to be trading for $51. And we expect to receive a dividend of $5. And then we're going to turn around and immediately sell it for $51. All right, so these are the cash flows that we are projecting. The 50, obviously, we're certain of because that's what it's trading for today. The $51 price 1 year in the future and the $5 dividend are projections. So we're going to kind of put a pin in those pieces and hold them down. We're going to hold those constant and say this is what we expect to happen. Right? And what we're going to do is find the rate of return on this investment if these are the actual cash flows that we experience. Okay, step 2, what type of cash flow are we looking at here? We've got just a series of lump sum cash flows, right? We've got a price today, we've got a price in the future, and we've got a dividend, not necessarily related by, I guess it's only one period. You could say there's a growth rate there, but that kind of doesn't make sense to talk about applying a growth rate in terms of something like a growing perpetuity or growing annuity when we've only got one period and a single cash flow to deal with. So we're just going to treat these guys as lump sums. Once we know that it's a lump sum, we know that we've got 3 tools that we could use. We could use the present value of lump sum formula. We could use the time value money keys on a financial calculator or a spreadsheet. Spreadsheet, of course, we won't look at just because that is typically not accessible during an exam. All right, so the formula setup, I do want to walk through this because there's still an error in the text. It was fixed at one point and now it's popped back up. I've made the publisher aware of it. I hope they'll get it fixed soon, but here we are. So for the formula setup, we're going to use the present value of a lump sum formula, where here we know the present value of $50. The future value is that $51 price plus the $5. It's okay to go ahead and add those together because they happen at exactly the same place on the timeline. These are both expressed in end of year $1, so it's perfectly fine to combine them. What we know the number of periods is just 1, so we can fill that in. What we don't know is the rate that makes them true. So if we just collapse this a little bit to make it a little cleaner, we've got 50, the current price, present value, is equal to the future value of 56 divided by 1 plus some discount rate. So what we want to do is find that little r, find that rate that makes this statement true, that equates the current price with the present value of the expected future cash flows. Right? We can do that by multiplying both sides. We got to get that r out of the denominator, right? So we're going to multiply both sides by 1 plus r, which it'll cancel out on the right-hand side here. and it'll load over onto the left. So then on the left-hand side, we've got 50 times 1 plus r is equal to 56. We still want to get that r by itself, so we're going to divide both sides by 50. And when we divide the left-hand side by 50, it cancels out. And it's going to be 56 divided by 50 on the right-hand side. That's what this should be. It shouldn't be 60 divided by 50. It should be 56 divided by 50 is equal to 1 plus r. And then we can just subtract 1 from both sides. Here we can see that 56 over 50 is corrected and get that the r, the rate that makes this statement true, is 12%. And what that means is if we were to purchase the stock today, hold it for 1 year, sell it for $51, and receive the $5 dividend, our rate of return on that investment would be 12%. If you want to put that in the calculator, this would be a quick one to do with the time value money keys in the calculator. I just wanted to walk through the formula so we could see that error in there. I don't know how many folks are actually looking at the formulas. Set up in the financial calculator, I guess we can plug that in real quick just to see how it goes. So our N is 1. Let me start by clearing it out because it's just one period. So 1 is N. Interest rate is what we're looking for, so I'm going to skip over that. Present value is going to be a negative 50 because we have adopted the perspective of someone buying this stock. So it's going to be a cash outflow at time period 0, which we'll punch in as a negative. You could either, there are several ways you could handle this. I chose to just add the future value together, or add the two cash flows together and record it as 56 here because that's what we did with the formulas. So it's just being consistent there. Since it's only one time period, you can split these up if you want. You could put 5 on the payment and 51 on the future value. You could put the 56 on the payment, record future value and 0. It doesn't really matter. Wherever you put it, the calculator knows that it's just one period later. There's only one of these cash flows, and it happens, one period from the present value. So it doesn't really matter how you split these up. I'll enter it just like it appears. So 0 is payment, 56 cash inflow, so positive is future value, and then we can compute I over Y, and we'll get that 12% back. Okay, so again, it's going to get confusing with the next example, so I want to be really clear what we just calculated. What we just found, it was based on the current existing price and what we expect the future cash flows to be. So what we just found is the expected return on this investment. If we were to buy it today at the price it's trading for, we think it would return 12% for us if our projections are accurate.